Meet the frog species called Glyphoglossus molossus, which members can inflate like a balloon. Remember that scene from the first Shrek movie? It works roughly the same here, only without any strangers involved. The frog inflates on its own. There are several reasons for such behavior, and all of them have to do with avoiding death. First, if you inflate, you'll look bigger, and this may scare away predators. Second, if you inflate, you'll get so tightly stuck in your burrow a predator will never pull you out. And finally, if you inflate, you'll become a big balloon, which is hard or even impossible to swallow. Basically, the strategy is to inflate yourself every time you don't know what to do. How much a frog can inflate is clear from the photo. Here, the male is bellowing, calling for a female with its whole body filled with air. So if necessary, these amphibians can get really big. It's even better when you're not just hard to swallow, but also impossible to grasp. Are you familiar with the strategy of shedding your tail to evade a predator? Well, it's hopelessly outdated. Something more interesting is trendy now: biting your own tail. At least this is the strategy the armadillo-girdled lizard has mastered. That's a lizard found only on the west coast of South Africa. The reptile bites its own tail to activate its sharp armor, the spines on its back. This way, the lizards make predators uncomfortable because they don't know which side to approach their prey from. Besides, in this pose, the lizard protects the most vulnerable part of its body, its abdomen, which has neither armor nor spines. Another lizard species that does something similar is the Namazonorus campbelli, but its representatives have slightly different goals. See these cracks in the rocks? These are the lizard's favorite habitat, and they're safe inside. Well, almost safe, because the animals that prey on this lizard, like snakes and baboons, can pull them out of there. That's where biting their own tails might come in handy. Look, when the lizard isn't curled up, its back is almost smooth. You can hardly prick someone with those spines. But when in danger, its body curves, which makes its sharp spines cover the whole surface of the lizard. They're pointed upwards, so this strategy can prevent predators from getting the lizard out of the crevice. As the baboon extends its paw, it unexpectedly encounters the prickly spines and immediately realizes that this is not a good idea. A human would be hurt too, even if that human is David Attenborough.
Ow.
But the lizard already realizes that the danger's gone, so it turns around and runs back to its cozy crevice. However, such behavior is quite rare in this particular lizard species. Researchers have observed more than 400 lizards in the wild, but observed them biting the tail only twice. Experts even have a theory of why this happens. Namazonorus campbelli runs faster than the armadillo-girdled lizard, and its armor is thinner. So in its case, it's more effective to just run away from the predator than to act as a spiny pretzel. It's interesting that Steve and I came across another lizard species that showcases a similar behavior. Strangely enough, the name of this lizard was not specified in the articles we found, but we found out that some lizards bite their own tails in order to become larger. By doing so, these lizards become too big to fit into the predator's mouth, effectively safeguarding them from becoming prey. This coyote won't leave the lizard alone, and it gets what it deserves. So there you have it, nature's most unusual defense mechanism. Large short-horned lizards are known for using their own blood to escape predators. The blood fills the lizard's eye sockets and at just the right moment shoots at the source of danger. Yes, literally. See how the blood oozes out of the corner of the eye? In a moment, it'll turn into a powerful jet. The thin blood vessels surrounding the lizard's eyes burst under pressure, causing blood to squirt out of the eye sockets. The pressure is so strong that the jet can shoot up to 3 feet away. But where does this pressure come from? Especially in such a small animal, as the lizard only grows up to 5 inches long. But the lizard found a way. It's developed muscular rings around the main veins flowing out from the head, and with these muscles, it pinches off the blood flow. The heart keeps pumping blood into the head where it stays, causing pressure and eventually swelling of the tissues around the eyes. All the predator needs to do is get within shooting range. He's clearly not thrilled, but it's understandable. The fluid that squirts from the eyes is not just blood, because the big short-legged lizards use their skill also for hygiene. Since they live in harsh habitats, dirt and dust often accumulate right in their eyes, and when you can't wash your face the more usual way, you have to improvise. But not only is blood mixed with dirt, it also has a very nasty taste. In addition, according to the researcher, the liquid also contains chemicals that can upset the stomachs of some animals, such as dogs, wolves, and coyotes. In short, lizards don't have to run away, they just shoot blood. and induce diarrhea. By the way, in addition to blood from the eyes, this lizard also uses inflating strategy to give the predator a mouthful of sharp spines. This gecko is stressed from being in human hands, so the scales of its skin just fall off. That's the basic defense strategy. Now to a little story. It happened on a November night in 2014 near the town of Darena in northeastern Madagascar. Scientists spotted two geckos. The larger gecko caught the smaller one and struggled to swallow it. In about 30 seconds, the little one suddenly managed to slip out of the predator's mouth, shedding all its skin. The happy animal, now pink as skinless flesh should be, flew through the air before landing and crawling to safety. It was as if nothing much had happened at all. And that's because some species of the Geckolepis gecko genus have developed the ability to shed most of their skin when someone grabs them. Their skin is covered with large scales that fall off easily. This is what a gecko looks like before it encounters a predator, and this is what it looks like afterwards. It's not a pretty sight. Gecko's incredible ability to evade attackers has been known for decades. It was unclear who the peculiar defense was intended to protect from. It has been suggested that, due to their tree-dwelling and nocturnal habits, these geckos might have evolved this defense to ward off nocturnal snakes. Though actually, skin shedding appears to be an effective means of defending against attacks from other geckos. But this is nothing compared to what spiny mice do. I mean, actually, the strategy is roughly the same. The tiny critters lose patches of skin when someone tries to capture them. And it doesn't matter who, a predator or an honest ecologist who just wanted to study the animal. When scientists discovered this unexpected peculiarity, they conducted a study and found that up to 60% of the skin can easily be ripped off the backs of spiny mice. The lab tests revealed that the skin of spiny mice is weaker than that of typical house mice. Instead of being elastic, as skin is generally supposed to be, it's brittle. Experts say they're not yet sure why spiny mice figured out how to part with pieces of their skin in the first place, but it's probably to stay safe from predators. Rodents are hunted by snakes and birds of prey, and losing their skin is clearly more preferable than any other outcome. It doesn't look very nice. Actually, it's very nasty, but it's clearly better than becoming someone's lunch. Fortunately, like many animals capable of shedding their body parts, spiny mice can quickly regenerate lost tissue. This is how the wound changed over 3 weeks, and 50 days later, it was completely healed. And here we can't even see a trace of the damage left. The skin on the back grows back completely, including the normal hairs, not leaving any scars, but regeneration isn't limited to the back alone. Researchers also found that mice were able to regenerate the missing skin in their ears. Very few mammals are capable of this, and as you can imagine, scientists became very excited about that. Today, this issue is being studied in more detail, and there's hope that we too will someday be able to grow skin as intact as that of the spiny mice. This ant grabs a larva from its nest and drags it to the surface because it wants to make a raft. Thousands of its fellow ants are doing the same. Drop a clump of 100,000 fire ants into a pond or flood the area they live in, the conditions don't matter. In a matter of minutes, the ants will assemble into a raft ready to float for weeks. As soon as the floodwater trickles into the tunnels under the ant colony, the fire ants begin their rescue operation. They evacuate the colony's babies, the larvae and the pupae, to the surface, then hold on to each other. Look, they lock their legs together like scaffolding and use their young to keep the raft afloat. Eventually, this structure holds up long enough for the water to drain off so that ants could go back to their safe home. Of course, the ants don't paddle or steer the raft, they're just willing to move wherever the current takes them. Fire ants' amazing ability to survive floods came from the fact that they evolved along the banks of the river. Without the ability to assemble in a raft, they simply would not have survived as a species. And this is what it looks like in the lab. A clump of ants assembles into a fully functional raft in just 2 minutes. Actually, the creators of the BBC Earth show Super Swarm believe that when water levels rise due to global warming, this unique ability will allow ants to move from America to Europe. To put it bluntly, this is not good news. However, even this survival strategy has its limitations. The water must not rise too fast. When Katrina flooded New Orleans in 2005, the water rushed in so fast that the ants couldn't even get out of their holes to form a raft, and they simply drowned. You know what's going on here? The antlion tosses away the empty shells of its prey. Insects trapped in a deadly funnel of sand have no chance of escape. They can only get out like this, already dead. And only one species of ant can escape the predator. It's Odontomachus bruneus, and its representatives figured out that they don't have to wait until they die. They just need to jump. It looks like a multiple somersault. Now look at those powerful mandibles. Usually an ant uses them for self-defense, snapping its jaws on predators to make them retreat, or for routine tasks such as digging nests and caring for ant larvae. And some ant species in the Odontomachus genus can snap their jaws at 525 feet per second, making it one of the fastest animal movements. But what about the antlion? When small insects or arthropods get into a pit and try to get out, the walls just collapse under their legs. But that's not the end. Look, the antlion throws sand at its potential prey, which can trigger an avalanche and make escape even more difficult. Once the insect falls to the bottom of the pit, the predator grabs it, drags it under the sand, and injects the toxin. Then all that's left to do is eat it. Meanwhile, according to research, when an ant can use its jaws, it has a chance to escape simply by jumping out and running away from the danger. By the way, this ant employs the same technique to gain speed and quickly notify its fellow ants about the potential threat. The antlion hunts ants, but there are animals that prey on the antlion, and these are, of course, birds. The larvae of this insect, that is, the creepy creatures that dig the pits of death, are especially vulnerable. Instead of actively defending themselves against the birds, the larvae resort to a passive strategy, lying completely motionless for unpredictable periods of time. And when I say unpredictable, I mean from a few seconds to an hour or more. In the study, one larva played dead for a record 61 minutes. The scientist who did the observing complained that watching paint dry on a wall was more interesting. And here's the kicker. It's believed that animals are playing dead to avoid being eaten by predators. However, larvae eating birds are indifferent to whether it's carrion or not. Scientists have found the logic behind this anyway. Birds react to movement, so the point is not to appear dead, but to be as still as possible. Perhaps the larvae are not even playing dead, but simply hiding in plain sight. The bird's brain is wired to favor moving prey over a non-moving one. If a larva, for example, has fallen from its beak and doesn't move for a long time, it just wastes the bird's time, and it's likely to go off in search of a more attractive prey, even if the motionless prey is right under its nose. To avoid the last-minute hassle of figuring out an escape plan, it's better to plan ahead. The prey can exhibit a distinct behavior that acts as a signal to the predator to stop it from wasting its time and energy. For example, lizards train for the same reason that the guys in the gym do, to show off their strength. A study showed that some lizards put on morning and evening shows every day. 4 species of male Jamaican lizards greet each dawn with vigorous push-ups, head bobs, and a threatening extension of the bright flap of skin on the neck. They repeat the ritual at dusk as well. Scientists believe that these displays of power help prevent real physical confrontations between male lizards. But that's not everything it does. Most importantly, the push-up shows help scare off predators. Gazelles have also been known to tell predators that they know when they're being watched. It's as if the potential prey is saying, "Hey buddy, your element of surprise is gone. I'm in good shape and I'll run away if I have to." But the gazelle, of course, cannot speak through its mouth, and so it resorts to stotting. This is a special behavior during which the animal lifts all 4 legs off the ground at the same time. Such jumps consume a decent amount of energy, demonstrating that the gazelle is in excellent physical shape. Here, these gazelles put on a show when they see a cheetah nearby, and the cheetah hesitates to attack. There's nothing else for it to do. Such jumps confuse predators so much that there were cases when lions stopped following stotting gazelles and started looking for other weaker prey. Both of these examples are so-called honest signals, which in the end benefit both animals. The prey increases its chance of survival, and the predator benefits from not wasting time pursuing an animal it's unlikely to catch. It's a win-win for everyone, and no one even has to shoot blood from their eyes. See you later.